All right, guys, as you were saying, you would have drawn your y-axis first. Then next we need to draw our x-axis. And now when we are drawing our x-axis, we need to take into consideration the y values. Now what we do, we look at the y values and we look at the positive y values and we look at the negative y values. So the largest positive y value has to be above the x-axis. So we want enough space to go up to that value. So this y value, which is 33, we need enough space to go up to 33. All right, now, one of the things that we want to do is we want to make our graph as pretty much sizable as possible. The bigger the graph, the better it is. So the bigger your scale, it is the better your graph will be. So I'm encouraging you to use big scale when it is possible. All right, so to go up to 33, we are going to be using 2 of these centimeter box to be 10. So it means that we will need about 6. Now we're going all the way down to negative. The lowest negative value would be -6. So we only need enough space below to go down to -6. So if we take 6 of the centimeter boxes above the x-axis, we'll be able to put the values of the positive y values, we will be able to put those in comfortably. All right, so we'll put the x-axis here because when we take the centimeter boxes, we're using a scale of 2 centimeters to be 10. So here is 10 on the y-axis. And we're using another 2 centimeters, that would give us 20. And then we're using another 2 centimeters, which would give us 30. And our value goes all the way up to 33. So this would be okay in terms of our scale. Now we have 0 at the intersection of the 2 axes. And then now we go down with the same scale. We will go down 2 centimeter units, and that would be -10. All right. All right, so once we have our scale for the y, we now need to put in our scale for the x. So we can use 1 centimeter to be 1 unit on the x-axis. So we can put 1, +1 there. We can put +2 in the next centimeter. Then +3. And based on the number of values that we have, we are only going over to 3. So we don't need any more really, but we can put an extra 4 in the next centimeter here. All right. And remember, guys, to label your axis. All right. And to put in your scale. So on the left side, we go -1 at the first centimeter. And then -2 at the next centimeter. All right, so here we have our axis labeled. So you put in your x and y. So this would be the positive x, negative x, positive y above, and negative y below. All right, and then you put in your scale. I'm not going to write in the scale here. I'll leave that for you to do. So now we are going to plot our points. So we are looking for x equal to -2 with y equal to +33. So, all right, so when x equal -2, we are going up to +33. So we are going all the way up the top here. So this is 30 up here. And so we want to go up to 33. Now, how many, one of these tiny boxes, what value would they have? So between 20 and 30, how many tiny boxes you have?
10, sir.
10. So it means one of the tiny boxes will be counted as what?
1.
1. And if we want 33, it means that we're going to go 3 tiny boxes above 30. And then we go across to where we would have -2, and we mark our points. And that's where we have our first point. All right, so our next value would be x -1 and y +8. So -1 with x, y +8. Now we go 8 tiny boxes up, come across to -1, and that's where we get our next point. Now the next point would be x equals 0 and y equal to -5. So we look for x equals 0, which is here, but on the y-axis, we are going down to -5. So we go down 5 tiny boxes, which would bring us right here. All right, so what we need next now is x equal 1, y equal to -6. All right, so x equal 1, y equal to -6. We're going to come down. So we go +1 and come down -6. So we're going to go 1 box below the 5. So that's right here. And then now we're going to have x equal 2 with y equal +5. So when you go to x equal 2, +5 is right here. So that's where we're going to draw our next box. And then now x equals 3, and then we're going all the way up to 28 for y. So x equals 3 going all the way up to 28, we go 2 tiny boxes below 30. All right, so those are all our points. And so what we need to do now is to connect these points, draw a smooth curve as accurate as you possibly can, but you're going to do it free-handedly. You're going to hold down your pencil and not lift it off the graph paper. Make sure you have a very sharp pointed pencil. And then you try as best as possible. Well, that's my first try, but try as best as possible to make it as neat as possible. All right, so if you have to go slowly, you go as slow as you can. Now, we're going down to here. And then, oops. All right, we want to go up back here. And the next point we want to connect. We want to connect here. Oops. All right, this is not such a nice curve. Let me try again. So it's a little harder to do it on this. Well, it's not accurate, guys, but you get the idea. All right, now the key thing here, we are using this graph to solve the equation. So how do we solve the equation? We just simply look for where the graph cuts the x-axis. So it cuts the x-axis right here. So it's 2 places that it cut the x-axis. It cuts it right here, and it cuts it right here. Now, all we have to do on our graph paper now is to read the values at those points. Now, remember, between 0 and 1 on the x-axis, you have 5 tiny boxes. So one of those tiny boxes is going to be equal to how much units? Guys?
Sure, repeat.
You have 5 tiny boxes between 0 and 1. So one of these tiny boxes will be how much? 2. Right, good. All right. So would it be just 2? It wouldn't be 2. It would actually
2
be
millimeters, sir.
no, not millimeter. You have to measure it in units. All right, this is how you calculate it. So between 0 and 1, you have 5 tiny boxes. So what you do, you divide 1 by the 5. If you divide 1 by 5, you get what? 0 point what? 0.2. So each of these tiny boxes on the x-axis is 0.2 units. All right. So if you go 0.2, 0.4, 0.6, 0.8, then you get 0.10, which is the same as 1. All right, so what we want to do now is to read the values where it cuts the x-axis. So where it cuts the x-axis on the right side, this curve cuts the x-axis, you read the values that you have there. So you come across and you count from 0, you count 1, and then how many of the tiny boxes you have after 1 to where it cuts the axis. So you'd have 1.2, 1.4, and where it reaches here would be 1.6. So here we would have x is equal to 1.6 units. All right, so that's how so you look at the x value where it cuts the x-axis. All right, and here now on this side, you would have x equal to 0.2, 0.4, and then half of 0.2 would be 0.1, so this would be actually 0.5. So on this side, it would be, x would be equal to negative 0.5. So x equal to negative 0.5. Any question, guys? So that's how we use our graph to solve our equation. We just simply look at where it cuts the x-axis. All right, there are other techniques that we will probably see as we go along. All right, so if you have your graph paper, guys, I would suggest that you take a screenshot of the table, or if you want to take a screenshot of the entire page, the entire slide, and then you're going to practice this curve on your own, in your own time, because some of you don't have your graph paper now. All right, guys? So take a screenshot of this, and then now we're going to move on. Just raise your hand when you're finished doing so. All right, Ms. Cabrera is finished. Anybody else is finished? Ms. Waysome, Miss Brown, anybody else? May I know, Ms. Artie, may I know clear the screen and move on? All right, guys. So I'm going to clear the screen now. Anybody still trying to take a screenshot? All right. All right, moving now, guys. All right, so for the same graph, if we do it on this, you will look for where it cuts the x-axis, and then you read the value for x. Now, it has been estimated on this graph that the x values would be negative 0.5 and 1.6, which is pretty much similar to the value that we had gotten from the previous graph that we plot. All right. Now, here we have plot the graph of y equal to 2x squared minus 6 between x equal to 4 and x equals 6, and hence solve the equation. Now, in this case, we are solving 3 equations with one graph. Now, in order to do that, first we need to draw our table, and these are the calculations from our table. Now, I would suggest that you take a screenshot of this slide, and you can do the graph on your own in your own time. All right, so let me know when you're finished taking a screenshot of this. And so I will move on to the next slide. All right, Ms. Waysome, Ms. Brown, Ms. Cabrera, Ms. Dorothy. Is that it? All right, moving on, guys. So here we could quickly draw this graph. Now, if we are to draw this graph, we're going to put our y-axis so that we can go over 4 units to the left and 6 units to the right. Now, so what we notice here on this graph paper, our centimeter boxes may not go over enough to accommodate all of these x values. So we'll have to use a smaller scale to accommodate these values on the x-axis. So let us first draw our vertical axis. So if we are using 1 centimeter to be 2 units on the x-axis, then it means then we should be able to reserve about, we're going over to -4. So all we need is 2, we need 2 boxes to the left. And for the other one, we need 6 boxes, sorry, 3 boxes to the right, because they're counting by 2. So that means I could put my y-axis right here and then have enough space to go over to the left and go over to the right. All right. All right. Now, for our x-axis now, we look at our y values and look at the highest positive y value. We have 60. So it means that we have to leave enough space above the x-axis to go up to 60. Now we can use our scale on the y-axis. 1 centimeter equal to 10 units. And that means you would have to leave about 6 of the centimeter boxes above. All right. So if we have 6 centimeter boxes above, so we have 1, 2, 3, 4, 5, 6. That means we could put our x-axis around here. Oops. So if we put our x-axis around here, that will give us enough space above to go up to 60 and enough space below to go down to -6. All right, so going up above, we are going to go 10. Then we have 20, 30, 40, whoops, sorry about that. 50, and then 60 would be our work right there. And then we're going down -10, and then -20. All right, so we can label our y-axis. So we start off with 0 here, and then we have 10, 20, then we have 30, then we have 40, then we have 50, then we have 60, then we have down here we have -10, and then -20. And then now on our x-axis, where our scale going to be our scale going to be 2 centimeter equal 1 centimeter equal 2 units on the x-axis. All right, so we're just putting in our interval marks. And so now we can label our marks. So we're going to have +1 here. No, not +1. We're counting by 2, right? So that would be 2, 4. All right, going to 6. I could probably put 8 here. And then on the next side, we're going -2. And then -4. All right, so all we need now is to plot our points. So -4 with 30. So it means that we go to -4 and go y equal to 30. So there is y equal 30 here. So we go to -4 here. Next we go -3 and 15. Now -4 going to be -3 going to be in the middle between 4 and 2, and you're going up 15. So on this axis, 15 would be midway between 20 and 10. And then now -3 is between -4 and 2. So it's right in this middle box here. all right? And then now next we have -2 and +4. So x equal -2, y equal +4. Each of these tiny boxes on the y would be equal to 2 units. So we have 2, 4. So we are going 2 and 4. So we'll be right here. All right, so the next one would be -1 with y equal to -3. So -1 is between 2 and 0. And we're coming down -3, which is, remember each of these tiny boxes will be 2, so we go middle between here. So we have 1 tiny box, which is 2, and half of tiny box, which is 1. So we get right in the middle there. X equal to 0, y equal -6. Then we are going to come down to this third tiny box here for 6. And then now x equal to 1, and we're coming up -5. So we go 1 in between 2 and 0. And then we come up half a box, so it will be right here. All right, so the next one would be x equal to 2 and 0. So when x is equal to 2, y equals 0. So that will be exactly on the x-axis. So we come x equal 2 and y equals 0. When y equals 0, neither going above or below the x-axis here or on the x-axis. So that's when y equals 0. All right. So x equal 2, y equals 0. Now x equals 3, y equals 9. So 3 midway between 2 and 4 going up 9. 9 is a little below 10 in the middle of that box. So that's 3 and 9. Then we have 4 and 22. X equal 4, y equal 22. So 4 going up 20. And one of these tiny boxes would be 2. And then now you have x equal to 5 and 39. So 5 is midway between 4 and 6. And you're going all the way to 39, which is 39 would be in between the box before you get to 40. All right, so it's right here. And then now you have x equal to 6 with y equal to 60. So it's all the way up here. All right, so those are our points. And so next, all we need to do now is to try to connect these points and draw our curve. So we try to take it as smooth as we can. All right, so your curve should look like that. Now, the thing is, we now have to remember the equation that we are trying to solve. So let me go back to the equation, all right? So here are the equations. So, so one is 2x squared minus x, and then you have minus 6 equals 0. Now the one that we are plotting is the first one, and the next one. So we are going to write these equations on the other side. So 2x squared minus x minus 6 equals 0, and the other one is 2x squared minus 4, and the other one is 2x squared and minus x minus 9. All right, we're going to try to write those. Anybody remember what they are? Let me see if we have any good memories now. So we have the first one is what? 2x squared minus x minus 6 equal to 0. Is that the first one? The next one is 2x squared minus x minus 4 equal to 0. And the next one is 2x squared minus x minus 9 equal to 0. All right, now the one that we plot on the graph would be this one, the first one. So it means that if we are solving for the first one, we're just simply looking at where the first one cuts the curve, cuts the x-axis, right? Because this is the one that we plot, but the same one has similar properties to the others. If you notice, all of them have 2x squared minus x. The only difference in them is the last number. So here now, we are going to use this graph where it cuts the x-axis to solve the first equation, and then we'll have to make some adjustment to the second equation so that we can use the same curve to solve it. All right, so for the first equation, we look at where it cuts the x-axis, and then now we read those values. So here it cuts it at this point, and then it cuts it at the other point here. And if we read our x values at these points, then this would be about negative 1.6 or 7. So here x is equal to negative 1. Negative 1.6. Let's say 1.7. So that's for this equation. To the right, x is equal to 2. And we say each of these intervals would be equal to what? If you divide 2 by 5, divide 2 by 5, what you get on your calculator, please?
0.3.
0.3. That means one of those tiny boxes would be 0.3. So it means that if you have it cut into one tiny box, that means this x would be 2.3 approximately. So you have x on this side.
It says 0.5.
Huh?
0.4.
Oh, 0.4. All right, so this would give you then 2.4 on this side. Because we're reading 2 right here, and then one tiny box is 0.4, so it's 2.4. All right, so that's the value for the first equation. So the x value for this one would be minus 1.7 and then 2.4. Those are the x value for that one. Now we need the x value for this one. Now in order to use this equation, the same graph to solve this equation, what we want to do is to add a number to 4 to get it to be negative 6, as in the first equation. What you would add to 4 to give you a negative 6? Negative 4. What you add to negative 4 to give you a negative 6?
Negative 2, sir.
Negative 2. So on this side, you would add negative 2. But on this side, you also going to add negative 2, because both sides, when you're adding to an equation, you have to add to both sides in order for it to maintain a balance. So what you need to do now, once you add to the both sides to get the same value as the negative 6 here, on the right-hand side where you have negative 2, you're going to go, because this is your y value now. So y is equal to -2. So you're going to look on the graph where y is equal to -2. And then now, so remember one of those tiny box would be 2 units, right? So -2 would be one tiny box. So where you have x equal -2 would be right here. So we're going to draw a horizontal line right across y equal -2. So we'll draw a line right across and make sure that it cuts both sides of the curve. Everybody see that? Now, where it cuts the curve now, you're going to draw a vertical line to meet the x-axis. So you're going to come down and meet the x-axis with a vertical line. And now wherever on the x-axis that vertical line meets, wherever on the x-axis the vertical line meets, you read that value, right? So this on the left-hand side, that would be approximately, say, 1 point something. So this one would be -1 something. So for this equation, x going to be -1, approximately 1, let's say about -1.1. Now for the right-hand side, x would be approximately 2. All right. Now we are going to do a similar thing to the third equation. But now we have -9, but we need to get rid of, we want to get it to -6. So we want to get rid of -3. What will you do now?
Add +3, sir.
You would add +3. And you do it to both sides. So now y going to be +3. And then you do the same thing as before. You look on your y-axis for +3. Remember, one of these tiny boxes on the y-axis is 2. But we're going to the positive side and we're going to 3. So we want 1.5 tiny box here. So it would go